Okay, hi guys. I'm now going through some of the MCQ questions from this worksheet, stoichiometric relationship. So let's do question one by one. Take note that in paper one, no calculator is allowed. So basically you have to use your mental ability to do your calculations. Okay, so the first question is how many molecules are there in 27 grams of distilled water? Oh my God. Okay, so that means what must I do? Okay, I need to take 27. Okay. And then after that, I need to divide by the MR of water, right? Okay, which is 18, approximately 18. And then after that, you need to multiply by 6 times 10 to the power 23. Okay. So you see whether you see any pattern or not. Okay, I can see a pattern here that is uh I think I can divide by 3, right? I get a 3. And 23 divided by 27 divided by 3 is 9. So the answer is C. Yeah. Okay, so that's how you do your math in IB paper lah. Okay, okay. So that's how I get my C. Okay. Clear. Okay, good. Okay, so let's move on to the next question. What amount of carbon dioxide will be produced when you have 32 grams of methane completely burned? So again, you need to know that your methane is CH4 and has an MR of 16. That gives you 2 moles. Okay, 2 moles of methane. And when you completely burn, obviously, it will also give you 2 moles of carbon dioxide because every mole of methane will give you 1 mole of carbon dioxide, right? Because methane only have 1 carbon. If this question is ethane, we have 2 carbon, obviously the number of carbon dioxide will be multiplied by 2. So the answer will be B for this one. Okay? Easy. So that's how you should solve your MCQ fast. Question 3. How many oxygen atoms are there in 0.5 mole of pentahydrated copper sulfate? So basically, you can just take 0.5. Then after what do? You multiply by the number of oxygen. In this case, I can see there's a total of 9, right? And then after you multiply by 6 times 10 to the power 23. Okay. So that means I'll take 6 times 0.5, which is 3. 3 times 9 will be 27, and 27 will be this answer, which is D. Okay, good. Question 4. Okay. What is the total number of atoms in 3 molecules of propane? So in this case, you can see that the idea is 3 molecules. So each molecule of propane consists of 4, 5, 6, 7, plus another 3, 10, right? So each molecule contains 10 atoms. Huh? So that means if I have 3 molecule means 30 lah. Can? So in this case, the focus is molecule. You got it? Good. Question 5. Which contains the same number of ions as the Avogadro constant? So ions in this case refers to the cations and anions in total. So basically you can see this gives you 0.5 times 2. Okay, so that's the answer. Because the rest will be 0.5 times 3, 1 times 2, and 1 times 3. So that's not the answer. Because Avogadro constant is about 1 mole of something, right? Yeah, so that's the answer. Answer is A. Number 6, which molecular formula are possible for a compound which has the empirical formula of this? So what you can do is you can work out the molecular formula, which in this case will be C2H6O. So that's out. This one will be C3, wrong, C4. 1, 2, 3, 4. C4, H. This will be 5. This will be 8, H8. And then O2, right? So that gives you the empirical formula C2H4O. So 2 is possible. And then if you look at this one, is C1, 2, 3, 4. And then oxygen is 2, hydrogen is 8. So basically both 2 and 3 are the likely answer, and the answer is C. Okay, very good, very easy. Which compound has the empirical formula with the largest mass? This question is super popular in all kinds of tests. So basically, when you look at empirical with largest mass, right, don't get conned by the answer D, because if you look at answer D, right, the empirical formula is actually CH. So if you choose D, GG, yeah, okay, because the empirical formula of C6H6 is actually CH. So it should look for, probably if you look at this one, it will be CH2, and of course, if you look at C, the answer will be CH3, okay? So the answer is C, yeah. So sometimes the teacher will change it to empirical formula with the smallest mass. So you just react accordingly, okay? Question 8, what is the maximum mass of magnesium oxide can be formed when 4.8 grams of magnesium react with oxygen? Okay, so this one you need to balance the equation. First of all, Mg plus O2 gives you MgO, right? And of course, I'm going to put a half here to balance the equation. So in this case, you have 4.8. Okay, and if I'm not wrong, the MR of magnesium is 24. And I believe this is 0.2. I think so. 0.2 moles. And that means the maximum mass will be 0.2. Okay. And if you multiply by the MR of MgO, it will be 24 plus 60, it will be 40. So that means if you take 0.2 times 40, that will give you 8 grams. Okay, that's the answer. You get it? Okay, so in this questions, right, you need to know how to balance your chemical equation. You need to know how to divide by the MR, and you need to know, do some simple math. And then after that, multiply by MR of MgO, you're able to get mass of your magnesium oxide. Okay. Number 10, which is the correct statement about the molecular formula of a compound? Okay, so molecular formula of compound, basically, of course, C is wrong. It's the simplest ratio that's out there. It's actually empirical. It shows which functionals are present in the molecule. It shows how the atoms are bonded in a molecule. It is an integral multiple of empirical formula. I guess the answer is this because it's basically n times empirical formula. That's answer D. Okay, number 10. Basically, this one is you need to do a bit of math. Basically, you have to take 84. Okay, and then after that, what must you do? You must divide by 12. Okay, and that means that the remaining will be hydrogen. That means that you have 14 grams of hydrogen divided by 1. So you have a 14 here. And if I'm not wrong, that gives you 7. Okay, the number of moles is 7. So if it's 7 and 14, that means that the empirical will be CH2. Okay, so the molecular formula is C7H14. We can make a guess if you take, because they tell you 98 grams, 对不对? So, no. Okay, there's no other information. They say that the molecular formula is C7H14. Is it possible? Let's check. Okay, I would go for 1 and 3 because I have not enough information to deduce the molecular formula. So I'm going for 1 and 3. The answer is B. Yay. Okay. Okay, 11. Basically, I have 32 grams of metals and reacted with 8 grams of oxygen to form an oxide. What's the formula? So what you can do is, you know that the oxygen, the AR is 16. That means this will be 0.5. Okay, and since 1 mole of oxygen atom gives you 1 mole of MO, that means that the number of mole of MO will be 0.5 moles. Okay, and what you can do is you can take gram per mole. That means you can take 32 grams divided by 0.5. Okay, that will give you 64. Okay, so that will be the AR of basically your M, if I'm not wrong. Okay, so that's how I'm going to do this question. Okay, how do I do it? I take 8 grams divided by 16. That will be number of mole of oxygen. And that means that there will be number of mole of MO. Okay, and using the formula gram per mole, I'm able to know that the amount of MO, or rather M, will be 0.5. And if I know the mass is 32, I take 32 divided by 0.5, and that will be 64. Okay? Okay, so that's how I do without calculator. Which is the maximum mass of iron in tons, which can be obtained when you take 40 tons. So basically, you can just take 40 first, no need to convert to ton. You divide by the MR, which is 160. That will give you about 1/4. And if this is 1/4, that means the iron will be 2/4, which is half, right? And if it's half, and if I'm not wrong, the MR of iron is 56, and that gives you 28. Therefore, the answer is 28 ton. Okay, then you just put back the ton, and then you get an answer. So it's 28 ton. Yep. And of course, this question is about ideal gas. And of course, which factors explain why the real gas does not behave like an ideal gas at low temperature and high pressure. Okay, the volume occupied by the gas is not negligible as compared to the volume of the gas. It is true because at high pressure, it means that the volume container is very small, it's no longer negligible. The attractive force between the molecules affects the pressure exerted by the gas. Wait, I don't understand. Never mind. The kinetic energy of a real gas is different to the kinetic energy of an ideal gas at the same temperature. Okay, very interesting. The attractive force between molecule affects the pressure exerted by the gas. Oh yeah, of course. Yes, because it's no longer ideal, right? So the attractive force will actually reduce the pressure of the molecules exerted by the gas. Now the kinetic energy of a real gas is different to the kinetic energy of an ideal gas, likely lah. Okay. So I'm going to choose all. I may be wrong, but I think that's the answer. Okay. And what's the maximum amount of methanol, okay, in moles, which could be formed when 4 moles of carbon dioxide, okay, is produced, or rather 4 moles of carbon dioxide. And then this one is 6 mole. So that means that if I have 6, right, that means that I only need 2. That means carbon dioxide is in excess, hydrogen is limiting. And if this is limiting, it will limit the formation of methanol. I'm going to divide this by 3. That means I'm going to have 2 moles. The answer is B. Okay? If you don't really understand, never mind. This is a video recording. You can just rewind, stop there and listen. Okay? So that's how you can repeat Mr. So for like 1,000 times. Okay? If I'm wrong, let me know. Okay. 15, which equations for the complete combustions of 2 moles of propane is balanced? Okay, what's the sum of the coefficients? So how do you do this? I'm going to balance this by using a 6 here because there's 6 carbon. I'm going to balance this by putting 4, right? Because I got 8, right? And after that, now I have 12 here and 4 here. That means I have a total of 16. I think so, right? 12 plus 4 is 16. Therefore, this is how many? 16. 8 lor. Okay, so 8 will be 2, 8, 6, 4. That will give you 20. The answer is C. Yay. Okay. So that's how I get my answer. And of course, this is basically a very old questions where they talk about room temperature 24. Anyway, never mind. Methane is 16. That means it's 2 moles, right? And if it's 2 moles, that means you get 2 moles of carbon dioxide, and that gives you 48 dm cube of carbon dioxide produced. Okay, and of course, what volume of this can be made from 30 cm cube of this? If this is 30, and if this is 60, we do try and error. If this is 30, and that means you need 90, not enough. So hydrogen is limiting, and hydrogen is limiting, you divide by 3 times 2, that will give you 40. Yeah, 40. What are we asking? 40 ammonia. So answer is A lah, so easy. Okay. And then after that, you have question 18. Ethane basically burn what volume? Okay, you have 0.8. So if this is 0.8, what am I doing? Okay, if this is 0.8, my God, that means you have to divide by 2 times 7. That means it will be 2.8. Okay, so that's the volume needed. Okay. And of course, 19, which solution contains the most amount of sodium hydroxide? I'm just going for number. I'll take this as 7 times 1. This will be 2 times 6. This will be 3 times 5. This will be 4 times 4. So that will be 16, 15, 12, 7. So 16 wins. I think so, right? So the answer is D. Okay, and after that, last question, yay, which is the correct statement about solution? When cholesterol dissolve in fats, basically fats is the solute, and cholesterol is the solute, fat is the solvent, yay. And of course, being fat is the solution, yes. Okay, so I guess the answer is this. Okay, let's check the rest. The concentration of solution is the amount of solvent dissolved, wrong, solute dissolved. And then when 1 mole per dm cube of sodium hydroxide containing 4 grams of this, don't think so. Okay, rubbish. And in solution of sodium chloride is the solvent and water is the solid. Wrong. Okay, so the answer is A. Okay, so that's how you should go about doing the MCQ. Okay, and yes, thank you. This is that chemistry guy. Where's my recording?